Hello, have a nice day. Now, an important feature of functions is that we can send our function some information, and our function can do something with that information that it receives. Let's say this time I would like to print hello plus somebody's name. Currently, name is an unresolved reference. What we can do when we call this function is send our function some information. This can be a value, a variable, a collection, all sorts of different things. So if you need to send your function some information, within the parentheses when you call that function, just list the data that you want to send your function. So let's say I would like to send my function a string value of bro, whatever your first name is. When you send information to a function, these are called arguments. They are the information that you're sending to a function. And when you define that function, you need a matching set of what is known as parameters. So our hello function is going to receive one argument, a string value. We need a matching number of parameters. Currently, this isn't going to work. You can see here that hello takes 0 positional arguments, but 1 was given. Our function needs a matching number of parameters. So think of it this way. When we receive this value, we're going to give a nickname to this value. So when we receive the string value, what do we want to call it? Well, let's call it name. So in order to add parameters to your function, just list the parameters within the parentheses of that function. And well, this should work now. We have a matching set of arguments and parameters. When we call the hello function, this time we are sending one argument over, and when our hello function receives this argument, we're going to give it a temporary nickname of name, or you can call this whatever you want to. And then we can use this value for whatever we want within our function. Now, if we were to run this, this will print, hello bro, have a nice day. Now I can send maybe a different value. Let's say hello, and then I will send a string value of dude. Hello dude, have a nice day. So this isn't limited to just values. We can send variables too. Let's say we have a variable called name equals bro. And this time I'm going to send this variable over, hello, and then send name. So these don't need to be the exact same. Let's say this is my name, and I'm going to send my name over, and I will temporarily give this value a nickname of just name. And then I can use this variable for something. Hello bro, have a nice day. Now, with arguments, you can send more than one value over. Let's say this time I would like to send 2 values over. So let's send bro, maybe for a first name, and code for a second name, but you can use your first name and last name. So this isn't going to work because we do not have a matching set of arguments and parameters. We're sending 2 arguments over, but our function is only designed to accept one argument because we have one parameter. So let's rename name as first name, and we need 2 parameters this time. So what are we going to call this value when we receive it? Let's call this last name. So this time we are going to receive 2 values. They will be nicknamed first name and last name. So this time let's print hello first name. Maybe I'll add a space plus last name. And this is now valid. Hello bro code, have a nice day. With arguments, you can mix and match the data types that you're sending as arguments. So currently we're sending 2 string values as arguments. This time, let's send an integer value. Let's say we would like to send an age over to our hello function. So I'll just send maybe the value of 21. So currently this isn't going to work because the hello function takes 2 positional arguments, but 3 were given. When we call this hello function, we're sending this argument over, but our function doesn't know what to do with this argument. So we need a matching parameter for this value that it receives. So let's call this value, maybe age, as a temporary nickname, and then we can do something with this value when we receive it. So let's print an additional message. Perhaps you are plus age plus years old. So if you need to display an integer or number along with the string, you do need to convert it to a string. So let's just cast our age as a string when we display this. So this should work now. We now have a matching number of arguments and parameters. So this will display, hello bro code, you are 21 years old, have a nice day. So ladies and gentlemen, in conclusion, a function is a block of code which is executed only when it is called. If I were to remove this function call, well then our program is just going to completely ignore this function and this block of code would not be executed. When we call this function, we can pass information known as arguments, but we need a matching number of parameters set up to receive these arguments. There are a few advanced features of parameters, but I'll hopefully get to that in future videos. We'll just stick with the basics for now of functions. So that's the basics of functions. If you would like a copy of this code, I will post this in the comments down below. But yeah, that is how functions work in Python. Hey, what's going on everybody? It's your bro, hope you're doing well, and in this video I'm going to explain the return statement in Python, so sit back, relax, and enjoy the show. Alright people, let's begin. The return statement is used within functions to send Python values or objects back to the caller. These values or objects are known as the function's return value. So do you know how with functions we can pass arguments to a function, and then our function can do something with those arguments? Well, not only that, but our function can pass some value or object back to the caller. So what we'll do for this example is create a function that will simply multiply two numbers together and return the result back to the caller. So let's define a function called multiply, and we'll set up two parameters for this function. Let's say number 1 and number 2. And what we'll do is say result equals number 1 times number 2. And then at the end, we can return something. What do we want to return? Let's return whatever the result is. Now, when we call this function, we will pass in two values as arguments. Let's say we would like to multiply 6 times 8. So when we run this, well, we can't actually see anything. When we return the result after multiplying numbers 1 and 2, it's going to return the result back to the caller. In order to see the value that is returned back to the caller, one way in which we can do this is to print the value that is returned within a print statement. So what we'll do is print the value that is returned after calling the multiply function. So 6 times 8 is really great. 6 times 8 is 48. Now, one other thing that we can do is store the returned value within a variable. So let's say x equals multiply 6 times 8, and then we will print whatever x is. So the result is still the same of 48. Now, with the return value, there is another way in which we could write this that uses less lines of code. So we'll delete this first line, and instead of returning a variable called result, what we'll do is just return number 1 times number 2. And this would work the same as it does before, but it's written in less lines of code. So that's another way in which you could write this. Alright everybody, so that is the return statement. Functions can send Python values or objects back to the caller. These values or objects are known as the function's return value. You can either print this value directly to the console window, or you can store it within a variable or some other location. And well, ladies and gentlemen, that is how the return statement works in Python. What's going on everybody? It's your bro, hope you're doing well, and in this video I'm going to explain keyword arguments in Python, so sit back, relax, and enjoy the show. Alright everybody, let's discuss keyword arguments. These are arguments that are preceded by an identifier when we pass them to a function. The order of the arguments doesn't matter, unlike positional arguments, which do matter, and we've been working with positional arguments already. And Python knows the names of the arguments that our function receives when we use keyword arguments. Here's an example of us using positional arguments, and then I'll demonstrate the benefits of keyword arguments. Let's say we have a function called hello that accepts 3 arguments, a first name, a middle name, and a last name, and the output will be hello, first name, middle name, last name. So if I were to run this, this will display hello, bro, dude, code. So we're using positional arguments. The order of the arguments does matter. What do you think is going to happen if I were to replace some of these values? let's say I will swap the first argument with the third argument. So let's try it again. Hello, code, dude, bro. So obviously the order of the arguments matters. And now if we were to use keyword arguments, then the order of the arguments doesn't matter, but with each argument, we need to precede each argument with a unique identifier. And that identifier is the name of the parameter we want to associate each argument with. So for my intended last name, I will use an identifier of last to match this parameter. So dude will be middle equals dude, and bro will be first, even though they're not in the correct order. So let's try this again. And my output is hello, bro, dude, code. So that's all about keyword arguments. They are arguments preceded with an identifier when we pass them to a function. The order of the arguments doesn't matter, unlike positional arguments, which do matter. And then Python knows the names of the arguments that our function receives when we use keyword arguments. So that's it for keyword arguments. If you would like a copy of this code, I will post this in the comment section down below. But yeah, that's how keyword arguments work in Python. Hey, what's going on everybody? It's your bro, hope you're doing well, and in this video I'm going to explain nested function calls in Python, so sit back, relax, and enjoy the show. Alright people, nested function calls. These are function calls inside of other function calls, and this is possible because certain functions will return a value, and we can immediately use that value as an argument for the next function. So here's an example. Let's say that we have this small program where we will ask a user to type in a whole positive number. And let's say I don't. Let's say I type in negative 3.14, and then I'm storing that value within a variable named num. What I'm going to do is convert that number to a floating point number because currently it's a string. When you accept user input, I will find the absolute value of num and then round it to the nearest whole number and then print the value. So we can actually do this using less lines of code with nested function calls. So let's start with the first function, which will be accepting some user input, the input function. So this will be in the very center of our nested function calls. And then the next function we would like to apply to the variable that is returned, the value that is returned, we will pass in as an argument to our next function of casting this data type to a float. So we'll surround our function with another function and use the float function. And then we'll just keep on adding layers to this. So we have the absolute value function next. So we'll add another layer. And we have the round function. So we'll add a layer to that. And lastly, we're going to print. And that'll be the outermost layer. So this program will do the exact same thing. Let's say negative 3.14. Except we've written this with one line of code. So basically, we start with the innermost function and resolve that first. Whatever value is returned, we use as an argument to the next outermost function. And in this case, it would be float. Then we resolve that, then move on to absolute value, then round, and then print. So it's just another way of writing code that takes up less lines, but this is more of an extreme example. You probably won't see like 4 or 5 nested functions. Well, everybody, those are nested function calls. If you would like a copy of this code, I will post all of this to the comment section down below. But yeah, those are nested function calls in Python. Hey, what's going on, people? It's your bro. Hope you're doing well. And in this video, I'm going to show you how variable scope works in Python. So sit back, relax, and enjoy the show. Alright, let's do a thing, people. Let's discuss the scope of a variable. Now, the scope of a variable is the region that a variable is recognized. A variable is only available from inside the region that it is created. Let's say that we have a function, and I just gave this function a name of display name. I created a variable inside of this function named name, and you can assign this a value of whatever your name is, preferably a last name for this example. And what I'll do is just print whatever my name is. So this variable is known to have a local scope because it's declared inside of a function. And a variable is only recognized inside of the region that it is created. This variable of name, since it's created inside of this function, it is known as a local variable that has a local scope. It's only available inside of this function that it's created. Now let's attempt to access this variable from outside of our function. So I'm going to print my name variable, but we'll have an issue though. So name is not defined. So local variables are declared inside of a function and they have a local scope. They are only available inside of this function in which they're created. On the other hand, a global variable is a variable that is declared outside of any function, but within your module that you're working with. A global variable is known to have a global scope. They are available inside and outside of any functions. Now, if I was to print my name variable, this is going to print bro, or whatever your first name is. And it is entirely possible to have both a global and local version of the same named variable. So we have both a global version of name as well as a local version of name. If I was to print my name variable from outside of this function, it's going to print my global version. However, if I print my version of name inside of that function in which it's created, we're going to first use the local version before the global version of name. And let's try that. So I'm going to call my display name function, and this will print my last name, code, and then my first name of bro. So it is possible to have a global and local version of the same named variable. Now, if I was to remove this line where we declare a local version of name, well then the next best available name to us would be the global version of name. So if you use a variable inside of a function, you'll first use a local version of that variable if it's available. If not, you'll use a global version instead. And Python will follow this rule known as the LEGB rule. You use any local variables first, then enclosed variables, then global, and then any built-in variables in that order. So that's the main difference between local scope and global scope. The scope of a variable is the region in which it's available, and it's limited to the region in which it's created. A local scope is available only inside of the function in which that variable is created. A global scoped variable is a variable that is available inside and outside of any functions, but within your module that you're working with. So that's variable scope in Python. If you would like a copy of this code, I will post this code to the comment section down below. And well, yeah, that's how variable scope works in Python. Hey, what's going on everybody? It's Bro, hope you're doing well. And in this video, I'm going to explain the args parameter in Python. So sit back, relax, and enjoy the show. All right, guys and gals, let's talk about args. Now, args is a parameter that will pack all arguments into a tuple. It's useful so that a function can accept a varying amount of arguments. Here's an example of why it would be useful. Let's say we have a function called add that will accept two numbers as arguments and add them together and return the sum. So this works as intended, right? As long as we pass in only two numbers. But what if we need to pass in three numbers as arguments? Well, we can no longer use this add function because we have two parameters set up, but we're passing in three arguments. You can see here within my console window that we have a type error. Add takes two positional arguments, but three were given. And one way in which we can solve this issue is to use this args parameter. So what we're going to do is replace all of our parameters with asterisk args. And actually, the args portion isn't as important as the asterisk. Args is short for arguments, and you can really name this whatever you want. Just be sure that you have this asterisk, because with this asterisk, we're doing a form of packing. What we're doing is passing all of these arguments and packing them into a tuple. So let's rewrite this program. So let's say maybe sum equals 0, and then we will need to iterate through all of the items within our tuple because tuples are iterable. So let's say for I in args. What we'll do is say sum plus equals whatever I is, and at the end, when we escape the for loop, we will return our sum. So let's try it again and see if it works. Well, would you look at that? It works. Let's pass in a few other arguments for good measure. Let's pass in 6 arguments this time. All right, look at that. This does in fact work. So you can actually name this whatever you want. The important thing is to have this asterisk. So let's rename this as, I don't know, stuff. And let's try this again. Yep, it still works. With tuples, they are ordered and unchangeable. Let's attempt to edit one of these values. So let's say stuff at index 0 is equal to 0, and let's try and change it. So you can see that tuple object does not support item assignment. if you need to change one of the values within your tuple after you pack all of these arguments, you might need to convert this to a different collection. One way in which we can do that is to cast it. Let's say stuff equals, and we'll cast our tuple as a list, because a list can be changeable, it's mutable. So let's attempt this again. We'll cast our tuple as a list, and then edit one of the values, and then add all the values together. So to change one of the values, say the name of your collection, stuff in this case, let's say at index 0, this now equals 0. So now if we were to add all these items together, they should equal 20. There we go. So yeah, that's basically the args parameter. The name isn't as important as the asterisk because you can really name it whatever you want. A common convention is to just name this args. It's a parameter that will pack all arguments into a tuple. It's useful so that a function can accept a varying amount of arguments. Well, that is all about args. If you would like a copy of this code, I will post this in the comment section down below. But yeah, that is how the args parameter works in Python. Hey, what's going on everybody? It's Bro, hope you're doing well, and in this video I'm going to be explaining quargs in Python, so sit back, relax, and enjoy the show. Alright everybody, let's talk about quargs. Now, this is a parameter that will pack all arguments into a dictionary. It's useful so that a function can accept a varying amount of keyword arguments. It's identical to args, except with args will accept a varying amount of positional arguments and pack them into a tuple. With quargs, this will accept a varying amount of keyword arguments and pack them into a dictionary. So here's an example of why this would be useful. Let's say we have a function called hello that accepts two keyword arguments, a first name and a last name. All this will do is output hello, your first name and last name. But what if somebody has more than two names? Let's say somebody has a middle name. And for this example, I'll just say my middle name is dude. So if I were to run this, well, this hello function is no longer going to work. As you can see in the console window, we have a type error. The hello function got an unexpected keyword argument middle. One way in which we can solve this, we can use this quargs parameter so we can accept a varying amount of keyword arguments. So what we'll do is replace our parameters with two asterisks, then quargs. Now, if I would like the same output as I had before, I'm going to need to change a few things around. In order to access a value within a dictionary, you type the name of the dictionary, square brackets, and then within quotes, list your key. So I would like to access the value at this key first. And let's repeat the process for last name. So the key is going to be last. We'll access this value at this key. And this should work the same as it did before. Now let's take this a step further. Let's say we would like to display somebody's full name based on the amount of keyword arguments that they pass into this function. Well, there's a few different ways in which we could do this. One easy way is that we could write our program like this. Let's print the word hello, and we will need to iterate once through each key value pair within this dictionary, and we can use a for loop to do that. So to iterate once through each key value pair in your dictionary, we'll type for key value in the name of our dictionary, quargs in this case, dot items, and then we will print each value. So there's one more thing that we need to do. This kind of works as intended, but it's going to print each value, including our word hello, on a new line. So with a standard print statement, this will print a new line character after each print statement as if we're hitting enter. We can actually change that. So after your string, add end equals, and we can replace that new line character with something else, maybe a space. And let's do the same thing for our for loop. So value, comma, end, and then just add a space. Now this will print all of your names all in the same line. Hello, bro, dude, code. And now we can pass in a varying amount of keyword arguments based on how long our name is. Perhaps we have like a title. Title equals Mr. And we can print that as well. Hello, Mr. Bro, dude, code. Here's a fun fact of the day. You don't necessarily need to name this parameter as quargs. The important thing is to have these double asterisks that precede it. Quargs is just a common naming convention. It's short for keyword arguments. You could name this as something else, perhaps something more descriptive like names, since we're passing in a bunch of names. So the name of our dictionary is now names, and this would work the same as it did before. The important thing is to have these double asterisks that precede the name of your dictionary, but kwargs is the common naming convention. Well, everybody, that's all about kwargs. It's a parameter that will pack a varying amount of keyword arguments into a dictionary. If you would like a copy of all this code, I will post this in the comments section down below. But yeah, that is how kwargs works in Python. Hey, what's going on, everybody? It's your bro. Hope you're doing well. And in this video, I'm going to teach you guys all about the format method in Python. So sit back, relax, and enjoy the show. Okay, ladies and gentlemen, let's begin. The format method is a method available to strings. It's optional, and it gives users more control when displaying output. To best demonstrate this, I'm going to use a line from a popular nursery rhyme titled, "Hey Diddle Diddle," because, well, you know, I'm a mature adult like that. I'll be printing this line to my console window. The cow jumped over the moon. Let's do so using a standard print statement, and then I'll show you the benefits of using the format method later. For this example, I have two variables, a variable called animal, and I'm going to store a string of cow, and item, and I'll be storing an item name, which is moon. When we compile and run this, as you would expect, the output is the cow jumped over the moon. There's a more elegant way of writing this line of code, and that is by using the format method available to strings. I'm going to turn this line into a comment, and we're instead going to produce the same output, but use the format method instead. So we need a standard print statement like usual, and then a string that we would like to format. So we're going to write the same thing, but in place of the variables, we're going to add a placeholder. Instead of the variable name or value name, I'm going to add a set of curly braces. So that functions as a placeholder for a value or a variable. This should be cow, jumped over and I'm going to insert another placeholder. Now this is a string. We can format the string by following this string with .format parentheses, and within the parentheses of the format method, we can insert some values or variables. Let's begin with some values. I would like to insert cow as well as moon. So this will produce the same output, but it's written a little more elegantly. We can also replace these with variables because they store these values. So I'm going to replace cow with animal and moon with item, and this will create the same output as it did before. These curly braces are what's known as format fields. They function as a placeholder for a value or a variable, and they work in order. The first format field will insert the first value at this location. If you have another set or more sets of this format field, you'll insert the next value that's listed within the format method. So if we were to switch these around, we'll switch the position of animal with item. Well, then the first format field is going to insert our item, and the second format field will insert our animal. This time, the moon jumped over the cow. An additional way of inserting values at a given placeholder would be to use what's referred to as a positional argument. Within these format fields, we will list the index of the value that we would like to insert at this location. If you need to insert the first value, well, that has an index of 0 because computers always start with 0. And following that pattern, the next index would be 1. If you had, let's say, 3 values that you need to insert, if you had another placeholder, that would be 2 then. So you would just follow that pattern. So there's going to be no visible change. But what we could do is reverse the positional arguments of these placeholders. So what do you think would happen if I switched 1 with 0 at these locations? Well, this format field is going to insert the value found at index 1. This first value is index 0, and the second one is index 1. So now the roles are reversed. This time, the moon jumped over the cow. Our last way of inserting some values at a given format field would be to use what's referred to as a keyword argument. Within the format method, we're going to list some keyword argument pairs. We need a keyword name followed by a value. So let's say animal is going to be the keyword. We're going to say equals some value. Animal equals cow, and item equals moon. And you may have noticed that the color of your text might have changed. So we no longer need these variables actually, but I'm going to comment out these two print statements because we will get an error then. So these are in keyword argument pairs. And within our format field, instead of keeping these empty or using an index, we can use the keyword name. At my first format field, I'm going to insert my keyword of animal. And at my second format field, I would like to insert the item keyword. So the result is going to be the cow jumped over the moon. So let's reverse these now. We'll place our item keyword here. And then at the second format field, we will insert our animal. And this time, the moon jumped over the cow. Here's an important concept that I'd like to bring to your attention. With these values found within the format method, you can actually reuse some of these more than once. So let's say we would like to state the animal jumped over the animal. We're going to use this animal keyword twice, and our output is going to be the cow jumped over the cow. If we're doing the same thing with positional arguments, we can reuse the same index. This time, let's say that the moon jumped over the moon. So our item has an index of 1. So within our first format field, we'll state the index will be 1, and our second format field will also be 1. So our output's going to be the moon jumped over the moon. All right, let's take things up a level. There's an even more elegant way in which we could write all of this. What we'll do is store our string that we would like to format within a variable. Let's turn this line into a comment, and let's create a variable called text. Text equals the string that we would like to format, which is the format field jumped over the format field. And if we need to format this variable, we can just call the format method on it. So within a print statement, let's say text dot, and then use the format method and pass in the values that we would like to insert at these placeholders. So we're going to insert animal as well as item. So our result, as you would imagine, is the cow jumped over the moon. In this next section, I'm going to explain how we can add some padding to a string when we display it using the format method. Let's say we have a name variable and assign this a value of whatever your name is. So I would like to display my name along with a custom message. Let's say, hello, my name is, and then I'll use a format field here. So let's follow this string by using the format method, and I would like to insert my name at this location. So currently this will display, hello, my name is bro, or whatever else your name is. So we can add some padding either before our name, after, or we can add some padding to the left and the right hand side of our value that we have. So what we'll do to begin is let's add some padding to the right hand side of our name that we have. So within our format field, if we need to add some padding, within the format field add colon, and then the amount of space you would like to allocate to displaying your value. So let's say 10. So I'm going to allocate 10 spaces worth of room to display my name. You can't really see it right now, but let's take a look. So I can't move my cursor past this line at the end of my name, but with my second line, I have all of this room to work with. So if I were to change my string that I have, let's say, nice to meet you, well then all of this padding that I have is going to be more evident. So we can add a number preceding with a colon to add some padding to a value. And then you can left align this, right align it, or center align it. So what I'll do is copy this line that I have. If you need to left align it, you use the less than sign, but there's going to be no visible change because that's already the default. If you need to right align, precede your number with a greater than sign. So your value is going to be right aligned. If you need to center this value, then use the caret. So this will center align your value within the padding that you have allotted. One question that you might have for me, and I'll try and answer that now because it's relevant. What if we need to add a positional argument or a keyword argument to our format field if there's already some text within here? So what you would do before the colon, you would just precede the colon with either your positional argument or your keyword argument, followed by colon and then whatever you want to add afterwards to format your value that you have. All right, ladies and gentlemen, we are near the end, and I promise that this is the last section. How can we format some numbers? Let's say we have a number variable, and this will equal the first few digits of pi, 3.14159. Let's pretend that we would like to display only the first two digits after the decimal. So we can do so using the format method. Let's print the number pi is, and then I'll use a format field here, and we will call the format method and insert our number that we have. So if I need to display only the first two digits after the decimal within the format field, I will add colon dot to f. F is for floating point numbers. That's anything with a decimal portion. So the result is that this will display only the first two digits after my decimal because we placed 2 within the format field. So if this was 3.3f, this would display 3 digits after the decimal portion. Oh, and apparently this will round your number, so that's something that you should keep in mind. So this time, let's change our number to something larger like 1000. And I will copy this line and make a few changes. Let's say the number is, and I would like to add a comma at the thousands place. So after the colon within the format field, I will add a comma. So this will automatically add a comma to all 1000th places. Another cool thing that you can do is that you can display your number as binary. So within the format field, add colon B. This will display a binary representation of your number. You can do the same thing with octal by adding colon O. So our number is now being displayed as an octal number, and you can do the same thing with hexadecimal, lowercase x for lowercase or uppercase x for all uppercase. So my number 1000 is now in hexadecimal. And lastly, we can display this number in scientific notation using either lowercase e for lowercase or capital E for uppercase. And my number 1000 is now in scientific notation. All right, everybody, so that's a few things that you can do with the format method. It's an optional method that gives users more control when displaying output. If you would like a copy of all the code that we've written here today, I will post everything in the comments down below. Don't be afraid to smash that like button, drop a comment down below, and subscribe if you'd like to become a fellow bro. Hey, what's going on, everybody? It's your bro. Hope you're doing well, and in this video I'm going to explain a few useful methods of the random module, so sit back, relax, and enjoy the show. Okay, people, in this video I'm going to explain how we can generate some random numbers as well as a few other useful methods of the random module. Now, we're not going to be creating true random numbers, but something called pseudo-random numbers, which are fairly darn close. So the first step is to import the random module at the top. Import random. We now have access to everything that the random module has to offer. Let's begin by generating a random number between 1 and 6, like we're rolling a dice. So what I'm going to do is say x equals random dot rand int, and we can generate a random integer between a certain range. If I want 1 through 6, I will state 1, 6, and then we can generate a random number between 1 and 6, like we're rolling a dice. So if I were to print the value of x, then we will get a random number between 1 and 6. For example, I just got a 1, a 2, a 3, and a 6. All right, we can also generate a random floating point number too. Let's say y equals random dot random. So this will give us a random number between 0 and 1. This time I'm going to print y. So we have 0.49 and some change, 0.145, and 0.858. We can also generate a random choice from a list or other collection. Let's say we're playing a game of rock, paper, scissors. So let's create a list. I'll just call this my list equals square brackets, and we will have 3 choices: rock, paper, and scissors. So let's say z will be the random string that we generate. Z equals random dot choice, and we will pass in my list. And let's print z. So this will generate a random choice from my list called myList. So we got scissors, paper, and rock. We can also use the shuffle method of the random module to shuffle a list or other collection. Let's say we're working with a deck of cards. Cards equals, let's say 1 through 9. And we have a jack, a queen, a king, and an ace. This won't be a full deck of cards, it'll just be one suit. So we can actually shuffle this list by using the shuffle method. Random dot shuffle. What do we want to shuffle? We want to shuffle our cards. And I will display my cards with a print statement. So the shuffle method will shuffle a list or other collection for you. Well, everybody, that's a few useful methods of the random module. If you would like a copy of all this code, I will post this in the comments down below. Don't be afraid to smash that like button, drop a comment down below, and subscribe if you'd like to become a fellow bro. Hey, what's going on, everybody? It's your bro, hope you're doing well, and in this video I'm going to explain exception handling in Python, so sit back, relax, and enjoy the show. Well, everyone, let's talk about exceptions. An exception is an event detected during execution that interrupts the normal flow of a program. Here's a program that I've written, and we're intentionally going to cause an exception. So this program that I've written, we will accept a numerator and a denominator from the user. We'll divide the numerator by the denominator, we'll get a result, and print the result. So what if I were to divide a number such as 5 divided by 0, which we cannot mathematically do? Well, this will cause an exception, an event detected during execution that interrupts the flow of a program. So our program was interrupted, and within our console window we have this traceback message, which states what went wrong and a name for this exception that occurred. This specific exception that occurred is a 0 division error. So this video is all about handling these exceptions so they do not interrupt the normal flow of a program. Now, a very basic form of exception handling is to surround any code that is considered dangerous, as in it might cause an exception, within a try block. Anytime you accept user input would be a good indicator too. So this code is considered dangerous because we don't know what the user is going to type in. So we will try all of this code. If an exception occurs, we can catch it and handle it. So to do that, we'll add an except block, except, and then we will catch exception. Normally, having this block by itself isn't considered good practice, but I'll explain why later. So this except exception block will catch all sorts of different exceptions, and it will prevent our program from being interrupted, and we can do something else entirely, such as print a message. Something went wrong. So let's try this again. We will divide 5 by 0, which we cannot do. We no longer have that traceback message within our console window. We caught the exception and we did something else. We printed something went wrong. Like I said before, it's not considered good practice to have a single except block that will handle all exceptions. It's much better to first handle specific exceptions when they occur, and we can do so by writing additional except blocks. So let's create an additional except block that will catch any 0 division error exceptions. That occurs when somebody attempts to divide by 0. So if this exception occurs, how do we want to handle it? Let's just print a message. Let's print, you can't divide by 0, idiot. And let's try this again. So 5 divided by 0. You can't divide by 0, idiot. Here's another one. I'm going to turn this except block into a comment so we can take a look at something. What if I divide by something that's not a number? Like we take 5 and divide it by the word pizza. Well, pizza's not a number, and we ran into a value error exception. So we should probably handle this too. So let's create another except block that will handle that. Except value error. And how do we want to handle this? Let's print something. Enter only numbers, please. Okay, let's try this again and see if this exception is caught. 5 divided by the word pizza. Enter only numbers, please. Not only that, but you can also add the except exception block at the very end, just in case there's something you won't anticipate. But it's always considered good practice to first catch any specific exceptions and let the user know exactly what went wrong. An additional way in which we can handle these exceptions is that we could display the exception that occurs, although it is completely optional. So to do that, what we'll do is that after each of these except block definitions, let's add as E. So we're calling the exception as E. That's just standard practice, although it's not necessary. So let's do that for each of these except blocks. And then we can print whatever E is. So let's add that to each of these blocks. So it should now look something like this. So when we encounter an exception, we can display what exception occurred to as well. So let's divide 5 by pizza. Invalid literal for int with base 10. Pizza. Enter only numbers, please. So like I said, this is an additional way in which you could handle an exception, although it's entirely optional. Another thing that you can do is that you can add an else statement to the end of your except blocks. So what's happening here is that we're going to try all of this code. If an exception happens, then catch it and handle it. If not, then do something else. So why don't we print our result only if there are no exceptions that occur? So if there are no exceptions, we will execute this else statement. If not, then we won't. So let's divide 5 by an actual number this time, like 2. So there are no exceptions that occurred, so we executed this else statement, whatever code is within our else block, and this printed the result of 2.5. But if an exception were to occur, like we divide 5 by 0, then we will catch our exception and handle it, and we do not execute whatever block of code is within our else statement. There is one other clause that you should be aware of. That is the finally clause. This is always at the end. How this works is that whether or not we catch an exception, we will always execute any code that is within the block of code for our finally clause. So this is a good opportunity if you open files to close them within the finally block, but we haven't dealt with opening files yet, so we won't do that. All we'll do is just print something. Print this will always execute. So whether or not we encounter an exception, this finally block will always execute at the end. So let's try this again. So this time, let's cause an exception. Let's divide 5 by 0. You can't divide by 0. This will always execute. And this time, let's take this seriously and divide 5 by another number such as 3. So this will give us a result. And like I said, the finally clause, the code within the finally clause will always execute. But we won't really be working with this until we get to the section on file handling. Well, everybody, those are exceptions in Python. They are events detected during execution that interrupt the flow of a program, and we can handle these exceptions by using try and except blocks. So if you would like a copy of all this code, I will post all of this in the comments down below. But yeah, that is how exceptions work in Python. Hey, what's going on, everybody? It's your bro, hope you're doing well, and in this video we're going to be covering some basic file detection using Python, so sit back, relax, and enjoy the show. Welcome, ladies and gentlemen, to the beginning of a mini-series involving doing stuff with files using Python, and in this video we're going to be doing some basic file detection. And in order to do so, I recommend importing the OS module. It's already included with the standard Python library. All you need to do is import it. All we'll be doing is checking to see if a file exists someplace on our computer. So we'll probably need a file to work with. What I'm going to do is go to my desktop for convenience and just create a new text document. I will call this test.txt. Now, I probably need the file location, so I'm going to copy that. And then we can use this. So let's create a variable called path that will include the path to the file that I would like to detect. So that was test.txt. Now, if you have backslashes in your file path, you'll probably need double backslashes because that's the escape sequence for a backslash within a string. So we now have this variable path that we can work with. Now, I would like to check to see if this location exists on my computer. So if os.path.exists. And you can see that we can pass in our path as an argument. So I will pass in my path, and if this returns true, if that location exists, I will print that location exists. So this will not tell me if this is a file or not. We'll be covering that later. Else, let's print that location doesn't exist. All right, so if this location exists, this will return true. If not, this will execute our else statement. That location exists. So what if I were to delete this file and we run this program again? That location doesn't exist. Now, this won't tell you if the location you're dealing with is a file or not. There is a separate function for that. It is if os.path.isFile. What we'll do is pass in our path and print that is a file. All right, so let's create another file because I deleted the previous one, test.txt. It's in the same location. Let's run this again. That location exists. That is a file. Now, what if this was a folder? So I'm going to create a new folder. I will call this folder. I will delete my test document. And let's change the location to folder. That location exists, but it is not a file. You can check to see if a location is a directory. So let's write an else if statement, os.path.isDirectory, and we will pass in our path. And let's print that is a directory. All right, so we have our folder. We're going to check to see if this location exists and if it's a file or a directory. That location exists. That is a directory. Well, everyone, that is the basics of file detection. We'll be building upon this concept in future videos. So if you would like a copy of this code, I will post this in the comment section down below. But yeah, that is the basics of simple file detection using Python. Hey, what's going on, everybody? It's Bro. Hope you're doing well, and in this video we're going to be reading a file in Python, so sit back, relax, and enjoy the show. Welcome back, guys and gals. In this video I'm going to explain how we can read the contents of a file using Python. So we'll probably need some sort of file to work with. I created a plain text file called test.txt. It's a plain text file, and all this says is, OMG, you can read this, have a nice day. Like, comment, and subscribe. So what I would like to do is to read the contents of that file line by line and print it to the console window. And here's how. And honestly, we only need 2 lines of code to do this. So what we'll do is type with open, then within the open function, list the name of your file or the file path. This file of mine is within my project folder, so I only need to list the file name. If this was someplace else, you'll probably need the file path. So let's say this was on my desktop. Well, I'll probably need to list the file path of where that file is located, and I'll need to use double backslashes because that's the escape sequence for a backslash. But since this file is within my project folder, I only need to list the file name. So with open, then the name of your file or the file path as file, then what we're going to do is print file dot read. And that is it. So let's test it. And it works. OMG, you can read this. Have a nice day. Like, comment, and subscribe. So this will actually close files automatically after opening them. So that's kind of convenient. And let's just test that theory. So I'm going to print file.closed. If my file is in fact closed, this will print true. If it's still open, this will print false. So normally when you read a file, it's normally open and you need to close it manually, but if you write your program this way, with open, this will close the file automatically for you. So using with open will close any files automatically for you after they've been opened. However, this does not catch and handle any exceptions that might occur, like if we cannot locate this file. So let's say that I mistype the extension for this file. Let's say that I type in test.tx. That's kind of funny because TX is the abbreviation for Texas. It's a Texas file. So this will cause a file not found error, and this will interrupt the flow of our program, and we would probably like to prevent that. So what we could do is write a try and an except block. So we will try all of this code. If we cannot find this file, we can handle this exception, file not found error. So we'll place all of this code within the try block. Then if an exception happens, we will catch that exception. Except we would like to catch any file not found error exceptions. And let's handle this by printing that file was not found. So if I were to run this again, we will catch and handle this exception, and this will not interrupt the normal flow of our program. Well, everybody, that's how to open and read a file in Python. If you would like a copy of all this code, I will post this in the comment section down below. But yeah, that's how to open and read a file using Python. Hey, what's going on, everybody? It's Bro, hope you're doing well, and in this video we're going to be writing files in Python, so sit back, relax, and enjoy the show. So to begin, it's kind of similar to the last video on reading files. With open, within the open function, list the file name or the file path. So what do you want to call this file? I will call this file test.txt. Now normally with the open function, there is a mode, and you can actually change that. There's a second argument that you can pass in. By default, this is R for read. But if you want to write a file, this would be W. So now we're going to write a file called test.txt. So to finish, with open as file, what are we going to do? File.write. And within the write function, we can write some text. So let's create a text variable and we will add a string. So let's say text equals yo. And if you need to go down to a new line, be sure to use the new line character. So after this new line character, the text that comes after is going to be on the next line, as if we're hitting enter. So, yo, this is some text. Have a good one. Alright, so after I run this program, we should have a file, a text file within our project folder that appears. And it is right here, and it says, yo, this is some text. Have a good one. Now, this is in write mode. If this text was something else, it will actually overwrite your current file. So if I were to change this to, this text has been overwritten, well then, this will overwrite the text that we have. This text has been overwritten. So you can actually append a file by changing the mode to A for append. So let me change this back. We will rewrite this. This will save over our current file. Now we can append some text. So let's add maybe a new line. Have a nice day. See ya. So I would like to append some text to this file. I'm going to change the mode to A for append. And we can now append some text onto the end of this file. Well, everybody, that's how to write to a file and or append a file. If you would like a copy of this code, I will post this in the comment section down below. But yeah, that's how to write to and or append a file in Python. Hey, what's going on, everybody? It's Bro, hope you're doing well, and in this video we're going to be copying files in Python, so sit back, relax, and enjoy the show. Welcome back to another video regarding doing stuff with files using Python, and in this video we're going to be copying some files. And in order to do so, I recommend importing the shuttle module. There's other ways of doing this too, but I tend to like using the shuttle module. Now, with this module, there are three basic functions to copy a file. Starting at the top, they are copy file, copy, and copy to. So copy file is what we'll be working with. This will copy the contents of a file. Copy will do everything that copy file does, plus copy the permissions mode, and the destination can be a directory. And lastly, copy to. This will do everything that copy does, plus it copies the metadata of that file, including the file's creation and modification times. So depending on the project or the program you're working with, you may need to use copy or copy to, but in this video, we're going to be using copy file just to copy the contents of a file. Now, after you import the shuttle module, this is all you need to do to copy a file. Shuttle dot, then use the appropriate function that you need to copy your file. We're going to be using copy file, and within this function, there are two arguments, a source and a destination. So within my project folder, I have a plain text file called test.txt. All this says is, yo, this is some text. See ya. What I would like to do is copy this file because it's cool. Now, since this file is within my project folder, I only have to list the file name. Otherwise, if this is someplace else, I would list the file path here. So this file is test.txt. This is the source file, and now I need a destination. So the second argument will be separated with a comma. I'm going to list a destination. So you can actually rename this too. I would like to name this as copy.txt. So the destination is my project folder. So when I create a copy of this file, test.txt, this copy will appear in my project folder and say the same thing. So after running this, we now have a file named copy.txt that says the same thing as my test file. And remember what I said, you can copy this file to a different location on your computer, so you could list the file path. So this file path would go to my desktop, and then when I run this, this will copy my original file, my source, and then copy it to wherever my destination is. Oh, and I almost forgot. So if you need to use copy or copy to, the arguments are exactly the same. So if you needed to use copy, this would be shuttle.copy instead of copy file. Then copy to is shuttle.copy to. The arguments are exactly the same, but each of these functions will copy different things depending on what you need for your own program or project. All right, everybody, so that's the basics of copying files in Python. I will post this in the comment section down below. But yeah, that is how to copy files using Python. Hey, what's going on, everybody? It's your bro, hope you're doing well, and in this video I'm going to explain how we can move files using Python, so sit back, relax, and enjoy the show. Welcome back, everybody, to another video regarding that thing that we do called programming, and in this video we're going to be moving files using Python, and in order to do so, I recommend importing the OS module. This is included with the standard Python library. All you need to do is import it. And now let's create two variables, a variable called source that will hold the location of where our source file is located, as well as a variable called destination to function as well, the destination. Now for this video, I'm going to move a file within my project folder to my desktop. So to do so, I'm going to create a new file. I will name this test.txt, but take the liberty to name this whatever you want. So I'm going to list the location of where my test file is located. Since this is within my project folder, I only need the file name. If this was someplace else on your computer, you would probably need the file path. And now, where would I like to move this file to? I would like to move this file to my desktop, so I just need the file path. So I'm going to go to my desktop, right-click, go to Properties. I'm going to copy this location and paste it within my destination. And I will add /desktop/test.txt. You can also rename this too if you want. I will just keep it the same. Now, if you have single backslashes, you'll likely need to change these to double backslashes because that is the escape sequence to print a backslash within a string. So we have a source location as well as a destination location. Now we can begin. I would recommend writing our code within a try and except block to handle any exceptions. So I would like to handle any file not found error exceptions, just in case our program cannot locate our source file. So let's print a message if that is the case. Perhaps source plus was not found. Now within our try block, let's check to see if there is already a file at this destination, because I would not like to save over it if there's already a file there. So let's do some basic file detection. If os.path.exists, and I will pass in my destination as an argument to the exists function. So if there is already a file here, I should probably let the user know. Print, there is already a file there. Else, we can replace our files. Honestly, if you do not care about saving over any files, you can omit this part. So else os.replace, and we will pass in our source and our destination as arguments. And let's print a message to the console window to let the user know that source plus was moved. All right, let's try this. Oh, I accidentally deleted my file, test.txt. All right, now this should disappear in 3, 2, 1. and it's gone. Test.txt was moved, and it should now be on my desktop, which it is. Now you can also use this to move a directory as well. I'm going to create a new directory. I will name this folder, and I will change source to folder, and the destination from test.txt to folder. And now this should move my folder. There is already a file there. Oh, let's delete that. Okay, folder was moved. All right, everybody, so that is how to move a file and or directory using Python. If you would like a copy of this code, I will post this in the comment section down below. But yeah, that is how to move a file and or directory using Python. Hey, what's going on, everybody? It's Bro, hope you're doing well, and in this video I'm going to teach you guys how we can delete files using Python, so sit back, relax, and enjoy the show. Alright, everybody, so in this video we're going to be deleting files using Python, and in order to do so I recommend importing the OS module. This is already included with the standard Python library. All you need to do is import it. And now we need a file to work with. So let's right click on our projects folder and go to new, file. I will name this test.txt, and we now have a file that we can work with. But you know what? I would like to delete this file because it's lame. So let's do that. In order to delete this file, let's type os.remove, and we're going to list the file path here. Since this file is within my project folder, I only need to list the file path, test.txt. If this was someplace else on my computer, I would probably need the file path like that. But since this file is within my project folder, I only need the file name. Another thing that you can do too, at least what I like to do, is that I like to pass in a variable called path. I will make this a variable and assign it a string value of whatever the path to my file is. So I will assign path, the name to my file, test.txt. Now, when I run this, this will delete my file, test.txt, and you can see that it's no longer there. Now, what if we attempt to delete a file that doesn't exist? Well, we'll encounter an exception. So if you want, this is optional, we can do some exception handling. So let's write the remove function within a try block, and we will catch this exception, file not found error. And let's print something. Print that file was not found. Now, if you attempt to delete a file that doesn't exist, your program will not be interrupted, and instead you'll print something, that file was not found. Now, this function does not remove empty folders. This is how to do so, and actually let's test that. So let's create a new directory. I'll call this empty underscore folder. Now, I will attempt to delete this empty folder. Empty folder. We encountered a permission error. Access is denied. So let's create an accept block for that. Accept permission error. Print, I don't know, you do not have permission to delete that. All right, to delete an empty folder, there is a different function. os.rmdir, short for remove directory. We're going to list the file path and pass that in as an argument. And let's create an else block as well because we can. Else, if there are no exceptions, let's print path plus was deleted. All right, so rmdir, remove directory, will delete an empty directory. Empty folder was deleted. Now, this function will not delete a folder that contains files, and let's try that. So let's create a new directory. I'll just call this folder. And within this folder, I will create a new file, test.txt. All right, let's attempt to delete this folder. I will probably need to change the file name. Let's change that to folder. And we encountered an OS error. That directory is not empty. So let's handle this exception. We don't need to, but I like to. Accept OS error. Print. You cannot delete that using that function. Okay, to delete a folder that contains files, we'll need the shuttle module. Import shuttle, and the function that we're looking for is shuttle.rmtree, short for remove tree, and we will pass in our path, Now be careful with this function, it is considered dangerous because it will delete a directory and all files contained within. So now we can delete a folder that contains files. Folder was deleted. In conclusion, these are three basic functions to delete a file or directory. They are remove, which deletes a file, rmdir, which is an abbreviation for remove directory, which will delete an empty directory, and lastly, rmtree, which is an abbreviation for remove tree, and this is of the shuttle module, and this will delete a directory containing files. So if you would like a copy of all this code, I will post this in the comments section down below. But yeah, that is how to delete files and or directories using Python. Yo, what's going on everybody? It's your bro, hope you're doing well, and in today's video I'm going to be discussing modules in Python, so sit back, relax, and enjoy the show. Alright, well, welcome back. We're talking about modules today. A module is a file containing Python code. It may contain functions, classes, etc. It's used with modular programming, which is this concept of separating a program into useful different parts. We're currently working within our main module, and mine is named Hello YouTube. This is how to create a separate module. Right-click on your project folder, go to New, Python file. I think I'll create a module filled with maybe message functions. So I'll call this Messages, and click Python file. Alright, we have two tabs, one for our main module, mine is called Hello YouTube, and a separate module for messages, and I can write whatever I want within here since we're using modular programming. I'll place a bunch of useful functions within this module, and I'll import them to the main module that we're currently working with. Let's define a function called hello. All this will do is print hello. Have a nice day. And I'll create a second function for good measure. Let's call this bye. Let's say bye, have a wonderful time. Now, if we would like access to this module, we need to import it. I will head back to my main module, and at the top, write this. Import, then the name of the module. And for this example, we used the name of messages for our separate module. And to use a function from that module, type the name of the module, dot, and then the name of the function. So messages.hello will call the hello function found within the messages module. And I can also call the bye function as well. Messages.bye. And that will print bye, have a wonderful time. Now, it can be somewhat tedious to have to write the name of the module followed by the function name. What we could do to shorten things up is to give our messages module an alias, also known as a nickname. So at the top, write import messages as, and what sort of nickname should we give messages? Let's say MSG for short. So we'll replace messages with MSG. MSG hello and MSG bye, and this would work the same and it involves less typing. There's also an additional way of importing a module, and it goes a little something like this. From the name of the module, import, and then list all of the functions or classes you would like to import. I would like to import hello, comma, bye. And we no longer need the module name before calling one of these functions. I can simply just call hello and bye directly. Another way in which this could be written is from messages import asterisk. That means to import all, and I actually would not recommend using this if you're working on a large program or something that contains many modules, because you can run into a naming conflict because some of these modules may have the same named function names or variables. So if you're working on a small program, I really don't think it's a big deal, but if you have multiple modules, I would actually refrain from using import all. It's much safer to write the name of the module followed by the name of the function that you want to use. Now, another cool thing is that Python has a bunch of pre-written modules that you have access to. If you would like a comprehensive list of them, type help and pass in the word modules. And within my console window, this will populate a listing of all the modules available to us. Here they are. Let's see if math is in here. Yep, there it is. So yeah, feel free to take a look through some of these modules because there's some fairly useful tools within some of these modules. I suppose you can also go to Python's official documentation and search for the Python module index, and here's a listing of all the different modules too that you have access to. Well everyone, those are modules. They are files containing Python code, and they may contain functions, classes, etc. If you would like a copy of all this code, I will post all of this to the comment section down below. But yeah, those are modules in Python. I guess there's a module called pickle. Hey, what's going on everybody? It's Bro, hope you're doing well, and in this video we're going to be creating a basic game of rock, paper, scissors in Python, so sit back, relax, and enjoy the show. Let's begin by importing the random module, because we're going to need the computer to pick a random choice. And we'll create a list of possible choices. So we have 3 strings within here: rock, paper, and scissors. I think I spelled scissors wrong. There we go. Okay, and we will have our computer pick a random dot choice from our list of choices. And let's test it by printing whatever the computer picks. So the computer picked paper, paper, scissors, and scissors. Okay, what about the player choice? Let's say player equals input rock, paper, or scissors. And let's print what the player has. Print player. And let's print the computer too. Maybe I'll add a string before these. So let's say computer, colon space, whatever the computer chooses. And the same thing with the player. Player. Alright, let's see if this works. Rock, paper, or scissors. Let's say rock. The computer picks paper, and I pick rock. So I would technically lose this round. Now, what if the player doesn't pick rock, paper, or scissors? What if they type in gun? So we would like some way to prevent that. So let's put our input for our player within a while loop. While player not in choices. So we're going to need to initialize player because right now it's an unresolved reference. So let's say player equals none for the time being. Okay, now let's test our choices, our player choices. Rock, paper, or scissors. I pick the gun. And it's going to keep on asking me until I pick something from my list of choices. So if I type in that, still won't accept it. Now let's type in rock again. There we go. Now what if somebody types in one of these choices, either all caps or capitalized? Well, that technically wouldn't be in choices because these strings are case sensitive. So why don't we take our user input and make it lowercase? And I'll just add on dot lower and use the lower method. So therefore we can now type in any input that is either all caps or uppercase, and then that will still be accepted because we're going to take our player input and then make it lowercase so that it matches one of these choices. Okay, let's work on the win conditions next. So first, let's check to see if we encountered a tie. If player is equal to computer, that means that we both chose the same thing. So let's print whatever the computer picked, what we picked, and we will print tie. Now let's write an else if statement. ELIF player equals rock. So if we pick rock, and then we will create a nested if statement. If computer equals paper, that means we lose. So let's print everything we have here, except we're going to change tie to you lose. Now if the computer picks, let's say scissors, then we win. So scissors, and you win. Okay, then let's just repeat this process for scissors and paper. So this will be another else if statement. If we pick scissors and the computer picks rock, then we lose. If the computer picks paper, then you win. And lastly, we have paper as the player choice. So else if player equals paper and the computer picks scissors, then we lose. If the computer picks rock, well then paper covers rock and we win. Now let's test it. Rock, paper, or scissors. Again, I'll try and pick the gun, which I can't. Let's take this seriously. I will pick rock. The computer picked rock, so it's a tie. I'm feeling like paper today. Oh, it's another tie, I guess. And how about scissors? Okay, so I win this round. I picked scissors, and the computer picked paper, therefore I win. Let's try and lose this time, just to verify it. So I won again. Let's try rock again. Okay, so I lost that round. So we know that the win conditions are working now. How about we add a feature where we will ask the player if they would like to play again, play another round. I think the best way to do that would be to write all of this code within a while loop. So at the top, let's write while true. And we'll need to indent everything so that it's within the while loop. So let's just indent everything here. Now at the bottom, we will ask the user if they would like to play again, and I will store this within a variable named play again. Play again equals input, and the prompt will be play again. Yes/no. And depending on their input, let's just make it all lowercase. If play again does not equal yes, that means they would like to quit. So let's use a break statement to break out of our while loop that we're in. And at the end, let's print by. And pay attention to the indentation. This input and this if statement should be within the while loop, so they should have at least one indentation. And our print statement here will just say by. And you can see that there is no indentation, so that is outside of the while loop. Okay, let's test this one last time. Rock, paper, or scissors. I'm going to pick the cannon. Okay, that's not valid input. How about rock? Okay, the computer picks rock. I pick rock, so it's a tie. Do I want to play again? I'm going to select, actually, yes, all caps. That should still be acceptable. How about paper this time? It's a tie again. Man, the computer's really good at this game. I'd like to play again. I'll pick scissors. Okay, so I lose. I would like to play again. And I want to win this time. Okay, computer picks scissors. I pick rock. You win. Do you want to play again? Nah. And it will print. Bye. Well, everybody, that's a simple game of rock, paper, scissors. I'll post all of this code to the comment section down below. And well, yeah, that's a basic game of rock, paper, scissors in Python. Hey, what's going on, everybody? It's your bro. Hope you're doing well. And in this video, I'm going to show you guys how we can build a basic quiz game in Python. So sit back, relax, and enjoy the show. To begin this project, I think it would be wise for us to create a skeletal structure for how this program is going to operate, and then we'll fill in the gaps later as we go along. So to begin, let's define all of the functions that we'll need. We'll need 4. We'll create a function that is named newGame. Whenever we call this function, it will create a new quiz game for us. And for the time being, let's write pass just as a placeholder. We'll have a total of 4 functions. newGame, a function to check our answer, a function to display our score, and lastly, a function to play again. All right. Now I'm just going to add some comments here just to separate each of these functions that we have, just so that it's a little bit easier to read, although this part is not really necessary. So I just want to separate each of these functions for some readability. Okay, those are all the functions that we'll need. What we'll need now is some sort of collection to hold all of the questions and answers that we have, and I think a dictionary would be perfect for this. So what I did is that I created a dictionary named questions. A dictionary has key value pairs. Each key is a question that I would like to ask, and each question has an associated value. We'll have the user guess between answers of A, B, C, or D. So these would be all of the correct answers, all of the values within this dictionary. So here are some of the questions that I want to ask. Feel free to come up with your own questions. If you would like, you can copy the questions that I have. they should be posted in the comment section down below. So the questions that I'm going to ask are, who created Python? What year was Python created? Python is attributed to which comedy group? And lastly, is the Earth round? I couldn't think of a fourth question, so I just threw in a random stupid question. And the correct answers to all of these questions in order would be A, B, C, and A. But feel free to come up with your own. Well, we have our questions, but we'll need some sort of collection to hold all of the different possible answers to each of these questions. And I think a 2D list would work perfect for this. So I have a list of lists. A list of tuples could work too, I suppose. So here are all of the answers for the first question. And the correct answer is A. I believe his name is Guido van Rossum. Hey, if you're listening, man, I'm sorry if I'm mispronouncing your name. I'm really trying here. The second list corresponds to the second question. What year was Python created? It was created in 1991, at least according to Wikipedia. Python is attributed to which comedy group? The answer is C, Monty Python, like Monty Python and the Holy Grail. Good movie, by the way. And lastly, is the Earth round? This is a highly debated topic, but the answer is A. The Earth is in fact round. So I have a list of lists. Each list corresponds to a key value pair within my dictionary of questions. And this is a lot to type. If you want, you can just copy the code that I posted in the comments down below. Just copy and paste it and you'll have all of this. Or if you want, you can pause the video and type it. I don't care. So now that you have your questions and your options, we're ready to begin. So the first thing that we'll do within our program is to call the new game function to begin a new game. So after we have our questions and options created, let's create a new game by calling the new game function. Now, when we run this program, we'll generate our dictionary of questions and our 2D list of different options for each question, and then we will call the new game function to begin a new game. So let's head to the new game function and fill in everything within our new game function. So at the top, let's declare a few things. Let's say we have a list named guesses, and guesses will be an empty list for now. I will declare a variable called correct guesses, set it equal to 0 because we haven't guessed anything yet, and we will set a current question number and set this equal to 1 to represent the first question. Okay, now we need to display all of the questions within our dictionary of questions, and we can use a for loop for that. So for key in questions, I'm going to print my key. And let's just test this. Okay, yeah, here's all my questions. I think what I'll do is actually print something to separate each question. Let's say one of these lines. I think it would look better with them. Okay, I'll print this line, and then we'll move on to a question. Alright, now after rerunning this, we have each question, and I added just a line break between each of these to make it look kind of fancy. Now, I need to display all of the different options for each question, and we can do that with a nested for loop. So if I were to write for I in options, print I, let me show you what happens. Now, with the way this for loop is written now, it's going to display all of the different options available to us for the entire quiz game. What I would like instead is to display only the first list for the first question, and then the second list for the second question, and follow that pattern. So we're going to change our for loop around. For I in options, and we'll set an index for options. The index is going to be our question number, -1. Now remember what I said in previous videos where different collections, including lists, tuples, etc., the first element in a collection has an index of 0 because computers always start with 0. Then the next element would therefore have an index of 1, then 2, 3, then you follow that pattern. We're using this question number variable as some sort of counter, and since we initially set this to 1, I'm just going to subtract 1 so that we effectively receive 0 as the index. And now we just need to increment our question number after each iteration. So let's do that. I will add that to the end here after we finish displaying all of the options. Let's increment question number by 1 by typing question num plus equals 1. And if I were to run this currently, we'll display all of the different options for each question. who created Python. Here's all of the associated options. What year was Python created? Python is attributed to which comedy group? And lastly, is the Earth round? Now it's time for some user input, so I'm going to create a variable called guess. And make sure you don't put it within your inner for loop. It should be within the outer for loop. Guess equals input, and I'll create a prompt. Enter A, B, C, or D. Here's something to consider. We would like the user to type in either capital A, B, C, or D. With strings, they're case sensitive. What if the user typed in one of these letters but lowercase? If they're correct, we would still like to give them their point. Why don't we take our guess and make it uppercase? So guess equals guess, and we can make this uppercase using the upper method of strings. At the end of this game, I'm going to compare our guesses to the correct answers. So we have an empty list named guesses, and I'm going to append our current guess that we're working on to our list of guesses. So guesses dot append, and we will append our guess this round. Now that we have our guess and we've appended our guess to our list of guesses, let's check to see if it's the correct answer or not. So we're just about to fill in this check answer function next. So we are going to call this function and pass in a few items as arguments. So let's use the check answer function, and we'll pass in the key for the current question that we're on. So the key is the correct answer. So that would be our questions dot get key. This would be the answer, and we'll also pass in our guess. And we are going to fill in the check answer function, but we need to set up the parameters. We're receiving effectively our answer as well as our guess. So I'm going to name these as answer and guess. And we are going to check to see if our answer is equal to our guess. If answer is equal to guess, let's print something. Print correct. And I think we should give the user a point. We'll have our check answer function return 1 for 1 point. Return 1. Else, if this is not the correct answer, let's print wrong, and we will return 0. They do not get a point. And since this is returning a value, we should assign that. So let's assign the point we may or may not receive to our variable of correct guesses, which is initially set to 0. So we'll type correct guesses plus equals check answer, and check answer will return 1 if we scored a point or 0 if we did not score a point. And make sure you have plus equals, because if you just set this to equals, then we cannot score more than 1 point. It will either be 0 or 1. So we are effectively incrementing our correct guesses by 1 for each point that we score. And now we're going to work on the display score function, and we'll call that at the end after we finish all of our questions that we have. So make sure that you do not write this within the for loop. It should be outside of it, because once we finish iterating through all of our questions, we're going to display a final score. So let's call the display score function, and we'll need to pass in some arguments, our correct guesses, as well as our list of guesses. Okay, let's head to the display score function. So we have, as parameters, correct guesses, as well as guesses. I need to remove this pass. I'm going to add one of these fancy lines in just to separate the questions from the results. And I will print results. And maybe another one of these lines. Okay, so I need to print all of the answers. Answers. And I do not want to end on a new line, so I'm going to set end equal to nothing. And I need to display all of the values within our dictionary, all of the answers. I will do that using a for loop. For I in questions, print questions dot get I, and I do not want to end on a new line, so I'm going to set end equal to nothing effectively. And then I'll print a new line. Okay, let's work on the guesses. I think I'm just going to copy all of this and make some changes. I'll replace answers with guesses. For I in guesses, print I. Okay, let's just be sure that everything's working. We're not calculating a score quite yet. So I'm just going to answer A, then B, C, and D. On second thought, after printing each of these answers and guesses, I'm going to add a space after each of these. So within each of these for loops, at the end, I will add a space. Let me try that again. A, B, C, D. Okay, not too bad. Now let's calculate the final score. And we're still within our display score function. Let's set score equal to correct guesses divided by the length of our questions. And let me add a set of parentheses around here. Then I'm going to multiply our score by 100. And if you don't want a decimal portion, because we'll display a percentage, we can cast this as an int. Okay, that all looks good. And we'll print the final score. Print your score is plus, we need to cast our score to a string because we're using string concatenation, plus I'll add a %sign. Alright, let's try it. I'm intentionally going to get the last question wrong, so we should have a 75% if we have 4 questions. So that would be A, B, C. Is the Earth round? What's Earth? I'm gonna guess D. Answers A, B, C, A. Your guess is A, B, C, D. Your score is 75%. Okay, let's test it, but getting all wrong answers. D, 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 D. Your score is 0%. Congratulations. And we'll test it one more time, but get all the right answers. We just want to be sure that we have 100%. That's A, B, C, A. Your score is 100%. Now, the last thing that you can add is that we can play again if we want, and I have a separate function for that. If you would like to add this option, here's how to do so. Let's remove that pass. Let's set a variable named response equal to some input. Do you want to play again? Let's ask for yes or no. Actually, let me remove that. Okay. And depending on the user's response, it might be lowercase, so let's make it uppercase. Response equals response, and use the upper method. If response is equal to yes, all caps, if response is equal to yes, then return true. Else, we will return false. And that is it for this function. The last thing we need to do is to create a while loop that will continue to ask the player if they want to play again. This will be after we call the new game function. While play again, and remember this will return either true or false, depending on the user's response. While play again, new game, and call the new game function to create a new game for us. If we escape the while loop, that means the user doesn't want to play again, so let's print a message. Such as, bye. Alright, let's test it. I'm going to get all of the correct answers this time. A, B, C, A. Alright, your score is 100%. Do you want to play again? I'm going to type yes. Alright, then we can play again. D, 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 D. Your score is 0%. Do you want to play again? No, I think I mastered this game. Bye. Alright everybody, so that's how you can use Python to create a simple quiz game. I will post all of this code to the comment section down below. But, well, yeah, that's a basic quiz game in Python for you all. Hey, what's going on everybody? It's Bro, hope you're doing well, and in this video I'm going to explain object-oriented programming in Python, so sit back, relax, and enjoy the show. Welcome to today's topic on Python object-oriented programming, also known as POOP, and in today's video we're going to be creating objects. An object is an instance of a class. By using programming, we can create representations of real-life objects. So look around you wherever you're sitting or standing right now. You are surrounded by objects. Next to me I have a phone, a television, some snacks, and I'm talking into a microphone. Point being, we can use programming to mimic real-world objects by assigning a combination of attributes, what an object is or has, and methods, what an object can do. Now, in order to create an object, we'll need to create a class. A class can function as a blueprint that will describe what attributes and methods that our distinct type of object will have. You can either create your class within your main module, or you could create a separate file dedicated solely for your class. Now, to create a class, we would type class and then the name of the object that we would like to create. So today I would like to create some car objects because I like cars. So we would type car. And a common naming convention with class names is that they should be capital. So car is going to have a capital C. And for the time being, we need to type in something. I'll just type in pass as a placeholder. So if you have a small program, it may be better to write your class within your main module. But if your class is fairly large, you may want to consider placing your class within a separate module. So if you were to take that route, we would go to File, New, Python file, and we would name this car, click Python file, and we would declare our class within the separate module. So class, car, and for now, I'll type in pass. Then we just need to import this class. So within our main module, we would type from the name of the module, import the name of the class. From car, import car. Now, objects can have some combination of attributes and methods. Attributes describe what an object is or has. So what are a few attributes that cars might have? They might have a make, so let's create a few variables. For the time being, I'm just going to use none as a placeholder. Cars can have a model, a year, and a color. Now, objects can also have methods. What kinds of methods could cars perform? Perhaps a drive method and a stop method. So let's define those. DEF, let's say drive, and we'll have one argument, self. Self refers to the object that is using this method. Now, what do we want to do when we call this method? Let's say this car is driving. Let's create a stop method as well. DEF, stop, and we will print this car is stopped. We now have all of the different attributes and methods we would like our car objects to have, but there is one more thing that we need. It is a special method called the init method that will construct objects for us. In other programming languages, this is known as the constructor. So we need a special method that will create objects for us. So we need to define this method, def, and the syntax on this is somewhat strange. It is 2 underscores, init. It's short for initialize, 2 underscores again, and then we need at least self as an argument. And then we can actually assign our car objects unique variables. So take all of these attributes that we have, and we're going to place them within this init method. Now we can receive arguments when we create car objects, but we need to pass them in as arguments to our init method. So we need to set up some parameters. Let's say in order to create a car object, we need a make, a model, a year, and a color. Then when we receive these arguments, we can actually assign them to each car's specific attributes, but we need to precede each of these with self. Self is referring to the object that we're currently working on or creating. So self.make, self.model, self.year, and self.color. And then when we assign these, we're going to say self.make equals whatever make that we receive when it's passed in as an argument, self.model equals model, and continue that pattern for year and color. All right, that is all we need for our class car. We have a constructor, we're assigning arguments that we receive to the attributes of our car object, and we also have two methods, one for drive and one for stop. Now we can start creating some car objects. So going back to my main file here, to create an object, we need a unique name for it. Let's call this first car just car1 equals the name of the class, car, then a set of parentheses. Now, in order to construct a car object, we need to pass in a matching set of arguments. You can see here that we need to pass in a make, a model, a year, and a color. So what kind of car should we make? Let's say that the make is going to be Chevy. We need a model, perhaps Corvette. A year, 2021 is good. And a color, let's say blue. All right, now let's actually access some of these cars' attributes. And I should probably put this within a print statement. So print car1's make, and this should print Chevy. Then we can do the same thing for model, year, and color. So let's change some of these around. Model, year, and color. Yep, this object is a Chevy Corvette 2021, and the color is blue. And we should have two methods as well. So car1, I would like this car to use its drive method. This car is driving, and let's have this car use its stop method. Car1 dot stop. This car is stopped. There's one thing that I should mention real quick because I forgot to mention it earlier. So within our init method, you can see that we need 5 arguments in order to construct a car object: self, make, model, year, and color. But when we pass in our arguments, we're not passing in anything for self. We only have 4 arguments here. That's because with Python, we do not need to pass in self. That's done automatically for us. We're referring to the object that we're dealing with. As you can see with our drive and stop method, we need to pass in self in order to execute our method. But when we call this method, we do not need to do so. So just remember with Python, with self, we do not need to pass in anything for this argument. That is all. Now, the nice thing about this is that we can reuse this class as a blueprint to create more car objects. We just call that init method that constructor. So this time, let's create a second car called car2. And this will be a different kind of car. What kinds of arguments should we pass in? Let's say this is a Ford Mustang. The year will be 2022, and the color will be red. All right, let's check car2's attributes. And let's have car2 use its drive and stop method. This is a Ford Mustang. The year is 2022. The color is red. This car is driving, and this car is stopped. One other thing that we can do too is that within our methods here, let's replace car with the name of the model that we're working with. So this plus self.model plus is driving. Now this self keyword, think of it as you're replacing self with the name of the object that we're working on. If car1 is using its drive method, replace self with car1. If this is car2 that called this method, then replace self with car2. Think of it that way. And let's do the same thing for stop. This plus self.model plus is stopped. All right, probably don't need these anymore. So let's have car1 use its drive and stop method. This Corvette is driving, this Corvette is stopped. Let's try this with car2. This Mustang is driving, this Mustang is stopped. Now you can have them do things independently too. Let's have car1 use its drive method and car2 use its stop method. This Corvette is driving and this Mustang is stopped. In conclusion, a class can function as a blueprint to create objects. We can assign attributes, what describe an object is or has, and methods, what each object can do. And then within our class, we have a special method called the init method. We can pass in some arguments and assign these arguments to each object's attributes. And then we can reuse this class as if it was a blueprint, so we can create more objects out of it. So that is the basics of object-oriented programming in Python. If you would like a copy of all this code, I will post this in the comment section down below. But yeah, that's the basics of object-oriented programming in Python. Hey, what's going on everybody? It's your bro, hope you're doing well, and in this video I'm going to explain the basics of class variables in Python, so sit back, relax, and enjoy the show. Here's a super quick video on the differences between class and instance variables. For this example, let's say we have two car objects named car1 and car2, and I'm just passing in a bunch of values to each of these car constructors. Now, within my class car, I have my init method, also known as the constructor, and what I'm doing is assigning all of these values to the variables found within my car constructor. These variables declared inside of the constructor are known as instance variables, and each object can have their own unique values assigned to each of these variables. Now, where a class variable is different is that a class variable is declared inside the class, but outside of the constructor. And what we can do is set some default values for some variables. Let's say we would like to add an additional variable. Let's say wheels. Wheels equals, and we can set a default value for all instances of this class for each car object that we create. So we set wheels to equal 4. This is an example of a class variable. Whenever we create a car object, we can pass in a unique make, model, year, and color. But by default, they will all have 4 wheels. Now, if I was to print the amount of wheels that car 1 and car 2 have, they will both have 4 wheels. It's as if we're setting a default value. If I change this to 2 wheels, well then these cars have 2 wheels. Maybe they're motorcycles or something. Now, you can actually change these values. Each object will have their own copy of this variable, but you can set it to a default value. So let's say car 1 is a motorcycle. Car1.wheels equals 2. So if I were to print car 1's wheels along with car 2, car 1 will have 2 wheels, but car 2 is still using that default amount of wheels, which is 4. Now, there's another way in which you can access a class variable. You don't necessarily need to create an object to do so. You can just use the name of the class. So what I'm going to do is turn all of these lines into comments, and I will print the amount of wheels that our class has. So type in the name of the class, car with a capital C. It should be the same name as your class name, followed by the name of the class variable, car.wheels. But make sure you spell it right. All right, so this will display 4 wheels. Now, what if we decide to change the class variable through our class? Well, that will affect all instances of our class. So let's say car.wheels equals 2. It's as if we change our mind and we have decided to create motorcycles instead of cars. Well, if we were to change the wheels class variable through the use of our car class, well then it's going to affect it for all instances of this class. You can see that both car 1 and car 2 now have 2 wheels. When we just changed car 1's wheels, it did not affect car 2 at all. So that's the main difference between a class variable and an instance variable. An instance variable is declared inside of a constructor, and they can be given unique values. With class variables, they are declared within a class, but outside of the constructor, and you can set a default value for all instances of this class, for all unique objects that are created, and then you can change those values later too. So if you would like a copy of all this code, I will post all of this in the comment section down below. But yeah, that is the basics of class variables in Python. Hey, what's going on everybody? It's your bro, hope you're doing well, and in this video I'm going to explain inheritance in Python, so sit back, relax, and enjoy the show. Let's talk about inheritance. The term inherit means to receive, derive, or be left with, and we can apply this concept to programming. Classes can inherit something, usually attributes and methods, from another class. These classes can form parent-child relationships, where a child will receive everything that the parent class has, much like you inherit genes from your parents, and classes can have children and give whatever they own to their children. And in today's video, we'll be creating a parent class called animal, and children of the animal class will inherit the common attributes and methods that all animals might have. To kick off this video, I think what we'll do is keep all of our classes within the same file, just so that it's easier for us to read and understand. Let's begin by creating a class called animal. So at the top, type class animal. And what are some attributes and methods that all animals should have? Let's say we have a class variable called alive, and we'll set this to true. If you're an animal, you begin by being alive. And what are some methods? How about an eat and sleep method? So let's define those. DEF, eat. What are we going to do when we call this method? Let's print something. Let's print this animal is eating. Let's also create a sleep method. DEF, sleep. What are we going to do when we call this method? Let's print something as well. This animal is sleeping. And we now have our animal class. Now let's create separate classes for specific types of animals. Let's say a class for rabbit, a fish, and a hawk, so we can make objects of those classes. So let's begin with a rabbit class. Class, rabbit. Now to use inheritance, with the class that you intend to be the child class, after the class name, add a set of parentheses, and then pass in the name of the parent class. In this case, it's going to be animal, so we will add that to the parentheses. So now rabbit is the child class, and animal is the parent class. So the child class is going to inherit everything that the animal class has. So for the time being, I'm going to type pass. So this rabbit class will have access to a class variable called alive, and an eat and sleep method. So let's define a fish and hawk class. And I'm just going to copy what I have here and just change rabbit to fish, and then do so again and change rabbit to hawk. This is our family tree. Animal is the parent class, and it has 3 children, a rabbit class, a fish class, and a hawk class. And for the time being, we're just going to write pass as a placeholder. So I bet we can create objects from these classes. So let's do so. Let's say we have an object called rabbit. Rabbit equals rabbit. Let's do the same thing for fish and hawk. All right, we now have 3 objects, rabbit, fish, and hawk. And let's take a look at their class variables. I bet they have an alive variable. Let's check that. So I would like to print rabbit dot, oh, would you look at that? This rabbit class has a class variable called alive, even though there's nothing within this class. Well, that's because we used inheritance. So each of these 3 children classes inherit everything from their parents, all of these attributes and methods. I bet they have eat and sleep functions as well, so let's check that. With fish, let's have fish use its eat method, and hawk will use its sleep method, hawk.sleep. So the rabbit is alive, the fish is eating, and the hawk is sleeping. Now, even though we have nothing written within each of these specific types of animal classes, all of these animals have access to these attributes and methods because of inheritance. And another benefit of inheritance is that we don't need to keep on copying and pasting this code. For example, let's say we were not using inheritance, so we would not need an animal class. We could write our code this way, where we would just copy and paste everything underneath each of our classes. So what if we need to make a change to one of these methods, as in your boss says, you know what, let's change sleep to slumber, okay? Well, we would have to go to each of these classes and make the change manually. It's not too bad if you have like 3 classes, but what if you have hundreds? That's going to take a lot of effort. So wouldn't it be nice if we just list everything that each of these classes has in common, and then have all of these classes inherit from one common class? And then if you need to make any changes, you can do so just within this class. And this change will apply to all of the different child classes. So that's another benefit of inheritance. And not only does it make any changes easier, but each class can have their own unique attributes and methods as well, along with the attributes and methods that they inherit from their parents. So for rabbit, fish, and hawk, let's have each of these classes have their own unique method as well. So for rabbit, let's define a run method. If you're a rabbit, then you can run. So let's print this rabbit is running. And I'm just going to fix some of the spacing here. All right, if you're a fish, then you can swim. DEF, swim. Let's print this fish is swimming. And lastly, we have hawk. If you're a hawk, then you can fly. DEF, fly. Let's print this hawk is flying. Like I said before, not only do these specific types of animals have access to all of the attributes and methods that they inherit from their parents, but they can have their own attributes and methods as well. So let's test some of these methods. So we have our rabbit, fish, and hawk objects. Let's have rabbit use its run method. Fish will use its swim method. And hawk will use its fly method. And here we go. This rabbit is running, this fish is swimming, and this hawk is flying. So in conclusion, classes can have children. The children classes will inherit everything that their parent class has, all of the parent's attributes and methods. But not only that, the children classes can implement their own unique attributes and methods as well. So that is inheritance. If you would like a copy of this code, I will post all of this in the comment section down below. But yeah, that's the basics of inheritance using Python. Yo, what's going on everybody? It's your bro, hope you're doing well, and in this video I'm going to explain how multi-level inheritance works in Python, so sit back, relax, and enjoy the show. Alright, welcome back everybody. Let's talk about multi-level inheritance. This is a concept where a derived class, also known as a child class, inherits from another derived class. Here's an example. Let's say we have a hierarchy of classes. There will be 3 levels to this. We'll create a family tree of living organisms. So at the very top, we're going to have a class called organism. Any class that inherits from the organism parent class will receive one attribute, one variable named alive, and this will be set to true. So if you are an organism, you begin by being alive. Now let's say we have a child class that will inherit from the organism parent class. Let's say animal. Class animal inherits from organism. So any animal that we create will have this alive attribute set to true. And all animals eat, so let's define a function that does that. At least I believe all animals eat. Let's pretend that they do. So this animal is eating. And now, why stop there? Let's create a class for a specific type of animal. I like dogs, so let's create a dog class. Class dog inherits from the animal class. And all dogs should be able to bark, so let's create a function to do that. And we'll print this dog is barking. Okay, so what we just did here is multi-level inheritance. We had a derived child class inherit from another child class. So it's kind of like this dog class is the child, animal class is the parent, and then the parent of the parent class would be like a grandparent, right? And then if you added another layer on top of that to this hierarchy, well then the parent of the grandparent would be like a great-grandparent. That's how I think of it at least. Now let's create a dog object just to verify that everything's working. So let's call our dog, dog, and our dog object should have access to an attribute named alive. And our dog object receives that attribute from the organism class. And this will print true if I were to print whatever this attribute contains. And our dog should be able to eat because it receives this method from the animal parent class. And lastly, our dog should be able to bark, and that method is defined within its own class. So that's how multi-level inheritance works. It's a concept where a child class will inherit from another child class. I like to think of it like a family tree, where a child class will have a parent, and the parent of that parent would be like a grandparent, basically. So if you would like a copy of this code, I will post all of this to the comment section down below. But yeah, that is how multi-level inheritance works in Python. Hey, what's going on everybody? It's your bro, hope you're doing well, and in this video I'm going to show you all how multiple inheritance works in Python. So sit back, relax, and enjoy the show. Alright people, multiple inheritance. Multiple inheritance is the concept where a child class is derived from more than one parent class. Here's an example. Let's say that all of our children classes are going to be certain types of animals, and we would like our animal classes to inherit from either the prey parent class, the predator parent class, or both depending on what type of animal it is, because some animals in the animal kingdom can be both prey and predators. And one example that comes to mind would be fish. Fish will eat smaller fish, but also can get eaten by larger fish. So here we have 2 classes, prey and predator. Each has a dedicated method. If a class inherits from the prey parent class, they will have access to a flee method, which will print this animal flees. If a class inherits from the predator parent class, that class will have access to a hunt method that will print this animal is hunting. And it's possible that some animals can do both. They can both flee and hunt, but they'll need to inherit both of these classes, both prey and predator. And that's where multiple inheritance comes in. Now let's create some classes based on certain types of animals. Let's say we have class rabbit, and rabbit will